So, in the last lecture, we had discussed introduction of the chopper. Second one is what is duty cycle. Third one, what is the application of chopper in our life. Okay. Fourth one is different types of the load. I have considering right now. I am considering only resistive load. Now later on we will go for the further loads. Okay. So now in the last lecture I have discussed one ideal chopper, ideal step down chopper. In the case of the ideal step down chopper, what we are doing in the we have seen that there is a two types of the modes are there. So in the mode number one, we have seen that there is a when the switch is on and when the switch is off. So we have a two possibilities over here. So when the switch is on, when the switch is off, what will happen? This current in the circuit becomes zero. So whole voltage will be blocked by this thyristor. Whole voltage will be blocked by this thyristor. So in the mode another mode, what we are saying that when the switch is closed, this output voltage is equal to the input voltage, but we are turning it on and off. So when we are turning it on and off, there is what T on period, how much duration of the time we are turning on this switch, and how much duration of the time we are turning off the switch. Okay, so T on and T off. So when you are making it T on and T off, you are getting the one complete time period. Okay, so yesterday we have also derived the output voltage function, that is the V output equals to delta into Vs. Vs is nothing but the input voltage which you are applying to the converter. Okay, so now yesterday we have discussed waveform of the ideal chopper. So again I am repeating that thing. Okay, so let's move on to the waveform of ideal chopper. Now suppose that you are applying the voltage over here, that is the Vs. So when you are applying the voltage over here, the waveform of Vs is what? Like this one. As you are applying the DC, so the magnitude will at any instant of the time, the output magnitude is not going to change. So if the output voltage is not going to change, so next what will happen? Output voltage is not going to change. Now in case of the power electronics, we have two terminals over there. Two terminal means what? There will be power terminal and one is the firing terminal. That is the firing terminal means what? There is a gate terminal over there. So if there is a gate terminal, you have two possibilities, that either you make a circuit on or off. So by firing it, suppose that we are turning it on and off. So when you are turning it on, this is the T on and this is the T off. So hold the completion of, means if you will add the T on and T off, you will get the one complete time period, because after one time period means what? After that the same waveform will appear again and again. Okay, so now this is Ig. So when you are turning it on, the output voltage waveform looks like this one. Okay, output voltage becomes this one. Next is what? The output, what will be the output current? Output current is nothing but whatever the peak voltage Vs by V output average by R. But only the difference is what? There will be the change in only magnitude, because you are dividing the value by a constant. If you are dividing the value by a constant, obviously the magnitude will be less. Okay, now next we will look on when the switch is off. When the switch is off, what is happening in the circuit? In the circuit, the whole current becomes zero. If the current becomes zero means what? The entire voltage will be blocked by this switch. So if the entire voltage will be blocked by switch, this switch will block the entire voltage. So obviously from during the T of time, the thyristor voltage will be blocked by thyristor waveform will looks like this one, and the magnitude of this will be what? Vs. Okay, so this is the thyristor voltage, this is the thyristor voltage waveform, Vt by Vt, because this is off period, because at that time the thyristor is on. If there is a on, there will be zero voltage across this one. So when this is off, there will be whole voltage will be blocked by this switch because the current over here is 0. If the current becomes 0, the whole voltage will be blocked by this switch. So that's why you are getting this much. Again, average current is nothing but the average voltage divided by R. Average voltage means what? This is the average voltage. Something, whatever the voltage you will get between these two, upper limit and the lower limit, between this you will get the average voltage. And we have also seen that we have also derived the output voltage in terms of input voltage. Okay, so input voltage is fixed, but you can change the duty cycle. If you will change the duty cycle, you can set a output voltage. Okay, because output voltage is a function of duty cycle. Okay, let's move on to the performance parameter of ideal step down chopper. Number one is average output voltage. How you are going to find this average output voltage? Okay, average output voltage. Average output voltage. At the output you are getting the waveform like this one, this one, this one. So this is what? This is the whole time is T on period. This is T off period. So V output average is nothing but area upon time period. Time period is what? From here to here, T on plus T off, that will give you what? Time period. So 1 by T, if you will integrate from 0 to T, 0 to 2 means what? From 0 to T on and T on to T off. Okay, so 0 to T, V output, this is what? V output, whatever the voltage you are getting, V output into dt is equals to what? 1 by T. 1 by T integration from 0 to T on, this will be what? This will be Vs, this will be the Vs into dt plus integration of T on to T, that is 0 into dt. Okay, so now if you will integrate this part, whole part becomes 0 because there is a 0 is over here, so whole part becomes 0. So now if you will integrate that, what you will get? You will get the V output average is what? Area by V output average, you will get that the peak voltage. This is what? Oh sorry, this is Vs. This is Vs because this is my duration of the Vs. This is Vs. So Vs into T on by T. So T on by T is nothing but the del. T on by T is nothing but the del. So if T on by T is a del, so V output average, we can find that Vs into del. So Vs into del is what? From the above expression we can conclude that. What we can conclude? That output voltage is a function of del. So if the output voltage is a function of del, output voltage is a function of del. Now suppose that if I am choosing some values of delta, so what will be the change in the output voltage? Let's see. If the delta is 0.1, so V output will be what? As you are seeing that the V output is a function of Vs. So 0.1 into Vs. After that, suppose that you are taking the delta, the value of the delta is 0.5. So if the value of the delta is 0.5, then again 0.5 into Vs from the above expression. Now if suppose the 0.8, so output will be 0.8 into Vs. So from the above table, what we can conclude that if your delta is going to increase, the output voltage is also going to increase. So output voltage is a function of delta. But one thing, if your the delta you can vary from 0 to 1. If suppose that if you will put a 0, the entire voltage becomes 0. But if you will put the delta is equals to 1, what will happen? If you will put the delta is equals to 1 from the above, if you will put the value of 1 in the above expression, you will get that V output average is equals to Vs. So there will be no change in the voltage. So whatever the input you are applying at the input side, same voltage is you are getting at the output side. Obviously if there is a no change in the output voltage, then there is a no significance of that converter. Okay, so obviously the value of the delta will be between from 0 to 1. You can vary from 0 to 1 according to your requirement. You will select that value. Okay, now let's move on to next term, that is average output current. Average output current. Average output current is nothing but it is just I0 average. You just divide that average voltage, whatever the voltage you have got in the previous page, that is this one, where it is, let's see, whatever the voltage you are getting in the previous page, you just divide that voltage, output average voltage divided by that resistance, that is average output average voltage divided by that resistance. You will get the average output current, and the magnitude of the current will be less than that. So, and we know that the output average voltage is what? It is a function of del into Vs by R. Okay. So hence in the above circuit, in the main circuit, we have discussed that it is what? It is a series circuit. Whole circuit is what? Whole circuit is a series circuit. If the whole circuit is a series circuit, there will be whatever the current is flowing through the switch current, source current, thyristor current, output current, all current are same, because in a series circuit the current is not going to change, and in a single wire there will be no flow of two current. It is not possible. Okay, so I output average, IS average, IT average is equals to what? Del Vs by R. So all the value are remain the same, because as it is a series circuit. Okay. Third parameter is what? Second parameter we have discussed. Third parameter is RMS. RMS value is nothing but the effective value. So RMS output voltage. RMS output voltage. RMS value is square, mean and root. Okay. So VOR is equals to under root of square root 1 by time period 0 to t on Vs square into d. You can see that the square, root and mean. Okay, so VOR is equals to what? Vs under root. If you will integrate that, if you will solve this thing, you will get the this expression, that is the t on by t. So it will be what? Vs into under root of del. Or you can simply find that if there is a t on and if there is a t off over this, so only what you will do, peak value is what? This is a shortcut approach. You will write the peak value Vs under root of how much duration of the time period the waveform has appeared, so this much duration. So you will write t on by whole time period. You will get the RMS value, RMS output voltage. Okay, RMS output voltage. Now let's move on to, this is the third one. Okay, sorry. Now let's move on to fourth one, that is the RMS output current. Simply only you have to just divide that output voltage by that resistance. You will get the RMS output current. So RMS output current is what? Only you have to just divide that whole term by VOR divided by R. You will get the RMS output current, and just divide this value by R. Whatever the value you have got in the above expression, you just divide by R, you will get the RMS output current. Okay. Form factor. Fifth. Right now we are discussing the performance of that converter. Fifth one is the form factor. Form factor. Form factor is nothing but RMS value by average value, output average value. So output RMS voltage by the average output voltage, you will get the form factor. Form factor is equals to what? So Vs under root del by V output, Vs, sorry, Vs into del. So we will get what? Vs get cancel out. So we will get 1 by root del. Okay, this is the form factor. Now let's move on to the next parameter, performance parameter, that is voltage ripple factor. Voltage ripple factor is nothing but what is the how much your voltage is fluctuating. Suppose that if you have made any converter, if suppose that there is a 5 volt DC is over here, you are making the 2 volt, but there is a fluctuation between this, your output voltage is varying, so this is called voltage ripple. This is called voltage, whatever the voltage fluctuation is over here, that is called voltage ripple. Okay, so voltage ripple is nothing but there is expression over here, that is the voltage ripple factor is equals to under root of form factor square minus 1. So form factor square minus 1, we have already derived the what is the value of the form factor. So 1 by del minus 1 equal to what? Root of 1 minus del by del. So this is your voltage ripple factor. Now I would like to plot a table of delta, form factor and voltage ripple. If suppose that we are going to change the value of the delta, what will happen? Whether the form factor will increase or decrease, or what will happen in the case of the voltage ripple factor. So suppose that we are assuming the delta, some values of the delta and some values of the delta. So this is what? Form factor. This is voltage ripple factor. So delta is what? 0.1. We are number 1 we are taking that the 0.1, 0.4, 0.7. I have calculated through my KLC. You can also calculate through the KLC. If you will put the value of the delta over here, you can easily get the value of form factor. If you will put the value of the delta over here, you can easily get the voltage ripple factor. Now I would like to see what will, whether with the increment of this delta, what will be the, it will increase or decrease, whether the voltage ripple factor will increase or decrease. So voltage ripple factor I have calculated in my KLC. So I have a direct data over here. So 3.16, 3.0, 1.58. The form factor is 1.58. Your voltage ripple factor is 1.224, 1.195, 0.654. From the above table, what we are seeing, if you are going to increase the value of the delta, the form factor is decreasing as well as voltage ripple factor is decreasing. Means what? Whatever, suppose that there is a fluctuation of, suppose that at this point the upper peak is what? Upper peak. Suppose that this is the upper peak. Upper peak is 2 volt and lower peak is 1 volt. So there is a fluctuation of what? 1 to 2 volt. So if I will increase the value of the delta, what will happen? This lower part will be shifted upward. So there will be less fluctuation over here. If the less fluctuation means what? Now there will be fluctuation of 1.5 to 2. So there is a reduction of 0.5. So if you will increase the value of the delta, there will be the reduction in the voltage ripple factor as well as form factor. So this is the delta. If you will increase, the form factor will going to decrease and voltage ripple factor is also going to decrease. So if form factor is direct, so form factor is inversely proportional to the delta, or you can say that voltage ripple factor is also inversely proportional to the delta. If it will increase, this too will decrease. Okay, this too will decrease. Okay, now next parameter is average thyristor voltage. Average thyristor voltage. Average thyristor voltage. area by, again area by time period, whatever the duration from the above waveform, you can see that whatever the waveform, what we have got, T on and T off, but at the time of the T on there will be what, the thyristor is on, so there will be zero voltage drop, but you will get the voltage only when the thyristor is off, because whole voltage will be blocked by the thyristor. So the thyristor waveform, the voltage will appear across only during the T off period. So from that you can say that T, we have already seen that T is what, T on plus T off. So if the total time period is T on plus T off, now I would like to find this duration. What we can write? So if you will reduce, if you will subtract from the T minus T on, what you will get? You will get T off. So if you will get the T off, and we have known that peak value is what, Vs, because whole voltage will be blocked by what, whole voltage will be blocked by that thyristor, so if the whole voltage will be blocked by that thyristor, then you have to write just Vs. After that T off, for how much duration it is off, how much duration you are getting the voltage, so T minus T on, so T minus T on by whole time period. The time period is what, because after one cycle it will going to appear, okay, after one cycle the same waveform will appear, so this will be T, so Vs into T minus T on by T. So average output, if we will calculate this, I think this will get average voltage across thyristor will be what, Vs into 1 minus del, okay, 1 minus del, because Tt becomes 1 and T on by T is what, delta. So this is your average thyristor output voltage, okay, thyristor voltage. Now Vs, now I just want to say that if suppose that the Vs is equals to what, Vt plus V0, Vs is what, Vt plus V0. So if just I want to verify that Vs equals to what, Vt plus V0, the circuit is what, the circuit is like this one, na? This is what, this is Vt, this is Vt, this is Vt, this is what, this is R, this is R. So if you will apply the KVL, means what, the Vs, this voltage is equals to this voltage plus this voltage. So if Vs is equals to Vt plus V0, so then obviously this average voltage is what, the average voltage of this means what, Vs into 1 minus del plus Vs into del. If you will solve this, what you are getting, Vs minus Vs del plus Vs into del. So you can verify that the whatever the supply voltage you are applying, the LHS is equals to RHS. So hence it is verified that if your output, if your average output voltage of the thyristor plus average output voltage, if you will add the average output voltage of the thyristor and the average output voltage, then what you will get, it will be equal to the source voltage, which voltage you are applying, okay. Now let's move on to the next performance parameter, that is power delivered to load. Power delivered to load. Power delivered to load. Power delivered to load. Let's go to power delivered to load. Okay. So power delivered is output power is what? Output power is a function of voltage and the current. So output power is what? Output power is equals to VOR. Output average output RMS voltage into IOR. Okay. IOR, or you can write VOR equals to what? IOR into R. So you can also write IOR square into R. Output power is also VOR square R. This is just a manipulation. If you will apply the V equals to IR, from here we are replacing one parameter, and obviously for every time we are getting some another expression. Okay, so whatever in the question, suppose that if the voltage is given, you will apply this formula, If the current is given, you will apply this formula. So according to the question, we will select that formula, what thing is given in the question. Okay. So now ninth parameter is what? Input power. P input is what? Vs plus Is average. Why it is Is average? Is average, Is average, Vs sorry, Vs into Is. P input na? Input voltage na? Input power, sorry, input power is what? Input power is Vs into Is average. So input Vs is Vs into del Vs by R average. So del Vs square by R. So you can say that input power is equals to output power. If you will replace over here VOR, you will get Vs square into del by R. If you are getting the Vs square into del by R, you can say that this input power is equals to the output power. So you can say that this P input power is equals to P output power, and this equation is called power balance equation. This equation is called power balance equation. Okay. So this is all about the performance parameter. Now we will move on to the next lecture. Okay, thank you.